Hi and a very good morning to my beloved lecturer and friends. First of all, I would like to thank our beloved lecturer, Madam Nitya, for giving us the chance to be here today. It was such a great pleasure for us to be here today to discuss some of the topic that we have prepared to present to all of you. And before we begin, allow us to introduce ourselves first. Starting with me, my name is Nur Atira binti Rozali and my matrix number is 01DKA20F2002.
Hi, my name is Nura Aimakis binti Muhammad Nazian. My number kat matri is 01DKA20F2023.
My name is Fadli Ahmad bin Hamad. My registration number is 01DKA20F2014.
Here, some of the content that we're going to discuss today. So let's get into it. Here is the team rules and their responsibilities. I, as the leader, is responsible to ensure that all the group members participate and divide the task to the group member equally. I also communicate with the members and keeps the group members aware of the time constraints and deadline.
I am a secretary of this group. My responsibilities is to take note and summarizing team discussion and decision and keep all the necessary record. Ensure the group members focus on most important issue and doesn't get caught up in details.
Hello, first of all, I am the innovator of the group. My responsibility is to strive to create harmonious and positive team atmosphere, encourage imagination and contribute new alternative perspective idea. He also responsible to fill the missing members whenever he need.
Next, I'm going to introduce you to differentiation. What is differentiation? Differentiation is used widely in solving problems, especially in engineering, medical, agriculture, and many other fields. When you find the rate of change of quantity, you are actually doing a differentiation. Another name for differentiation is the derivative of function. Gradient is equal to change of vertical height over change of horizontal height. Generally, to find differentiation of y with respect to x, you just need to write down the symbol dy over dx to represent it. So without wasting any time, let's get to know some of the basic rule of differentiation. Okay, so the first thing that I'm going to discuss with you is the basic rule of differentiation. As you can see on the screen, I show you some of the example on how the basic rule of differentiation works. So for the example, you have y equal to x power of 3. When you differentiate the y, you will have 3x power of 2. Next is the product rule differentiation. It works the derivative of product of two functions times the derivative of the second plus the second function times of the first. If you don't really get it what I'm saying, you can just look at the formula that shown in the screen. Dy over dx is equal to v du over dx plus u dv over dx. This is the example on how product rule function works. If you look at closely at the screen, it only uses the formula that I gave you before this, and you can answer the questions when you have the formula. Okay, the next function that I'm going to discuss with you is the quotient rule function. Okay, this is the formula that you need to know in quotient rule functions. Dy over dx is equal to v du over dx minus u dv over dx divided into v squared. This is the same with product rule functions. It's not the same, but you add a little bit by divided them into v squared. Okay, if you look at the screen now, you see one of the example on how to use the quotient rule function. If you look closely on the questions, you must see that if you want to use the quotient rule function, you must have the fractions number. The next function is trigonometric functions. This function is a little bit tricky because as you can see on the screen, you need to memorize all of them to differentiate the trigonometric function. Okay, so here is the example on how trigonometric function works. If you look closely on the questions, it's actually easy to answer the questions. I might say this a little bit tricky, but if you memorize all the formulas, it's actually easy to answer these questions. Okay, the next function that I'm going to discuss with you is the chain rule function. This function is a little bit easy, but you need to be careful on how to actually find the value of dy over du and du over dx. Okay, so this is the example on how chain rule works. If you look closely on the questions and the solutions, it is actually a little bit easy than the previous one. That's why I said that this function is actually a little bit easy, but you need to be careful on how you find the value. So that's all from me. I'm going to pass this presentation to Fadli Ahmad to continue the presentation. Thank you.
Slide. This slide is about example of real-life application of differentiation. Differentiation is very important in many fields and has made great contribution in this field, which are still noticed nowadays. In economics, differentiation can be used to calculate the rate of change of the ordering and transportation cost for the component used to manufacture a product, in which the cost is dependent on the other size. Now we go to the first example. The first example is calculus speed trap. If you see at the picture right now, it's about the one of police officer in United States of America. He and his gadget about the calculus speed trap. The explanation about is 3 students use a distance measure app to measure the distance between the gate of the school and the road, which was found to be 78 meters. One of the students extended his arm and followed different passing car until it hits a 45-degree angle. The other 2 students timed how long it took for each passing car and averaged the time. The second example is coffee maker. In the process of making coffee, coffee is draining from a conical filter into a cylindrical coffee pot at a rate of 10 in 3 or min as usually. The third one is consuming gas mileage. The gas mileage of an automobile is affected by many factors like road surface, tire type, velocity, fuel octane rating, and the speed and direction of the wine. The effect of the velocity on the gas mileage of a certain car is expressed in the function below. The last one, response of a plant to daylight changes. In London, the number of hours of daylight can be found using L in bracket T equal 12 minus 4.5 cos in bracket T, where T is the time measured in units to correspond to 1 year. A certain plant unfolds its leaf is the spring in response to change in day length.
I'm going to discuss the solution for the question given by Madam Nitya. Question: y equals 60x plus 3x power of 2 negative 4x power of 3. dy per dx equals 60 plus 6x negative 12x power of 2. Stationary point, negative dy per dx equals 0. dy per dx equals negative 12x plus 6x plus 60 equals 0. Bracket x plus 2 bracket 2x negative 5 bracket equals 0. When x equals negative 2, y equals 60x plus 3x power of 2 negative 4x power of 3 equal 60 bracket negative 2 bracket plus 3 bracket negative 2 bracket power of 2 negative 4 bracket negative 2 bracket power of 3. The answer is negative 76. When x equal 5 per 2. Y equals 60x plus 3x power of 2 negative 4x power of 3 equals 60 bracket 5 per 2 bracket plus 3 bracket 5 per 2 bracket power of 2 negative 4 bracket 5 per 2 bracket power of 3. The answer is 425 per 4. Stationary point are bracket negative 2, negative 76 and 5 per 2, 425 per 4 bracket. Min slash max dy per dx equal 12x power of 2 plus 6x plus 60. D power of 2y per dx power of 2 equal negative 24x plus 6. When x equals 0, d power of 2y per dx power of 2 equal negative 24 bracket 5 per 2 bracket plus 6. The answer is negative 54. When x equal to d power of 2y per dx power of 2 equal negative 24 bracket negative 2 bracket plus 6. The answer is 54. Bracket negative 2, negative 76, mean point. After you get intersection point, max and min point, you can plot that point to make a graph. I'm going to give some summary about this topic. Summary. Calculus is a branch of mathematics focused on limit, function, derivative, integrals, and infinite series. Calculus has widespread application in science, economy, and can solve many problems for which algebra alone is insufficient.